Okay, so this is your warm-up for today. It's going to take you a little bit of time, I know, but grab some graph paper if you're in the building. I have some back on that wicker shelf. Okay, there's blank paper, there's lined paper, but there's also graph paper back there. So grab some graph paper, and you're actually making 4 graphs total. So you can do 2 graphs on the front of the paper and 2 graphs on the back of the paper. You can do degrees on the front and radians in the back. Your degrees will go from negative 180 to positive 540 degrees. Your radians will go from negative pi to positive 3 pi. And both graphs will have a maximum y value of negative 1. A minimum y value of negative 1 and a maximum y value of 1. So 4 graphs. I know this is going to take you a little bit of time, but that's why you can pause. And when you have all 4 of them done, you can hit play and we can continue. Okay, so I know that took some time, but these are good references to have in your notes anyway. So hopefully you took your time and you did it neatly. Today we're going to be working with parts of the sine, cosine, and tangent graphs. So we're not really working with the unit circle as much right now, but we're going to be using graphs of sine, cosine, and tangent to be able to solve equations. So this is what your graphs should have looked like. Now, when I ask for certain values, you should be able to kind of line things up on here and find that. So if I said, for instance, we're working in degrees, so we're using the this one, and we want this one of these two is degrees, and we want the sine, so we'd go to this graph and we said, when does the sine equal 0.5? So we come up here to 0.5 and we can just kind of trace along this and estimate when the sine would equal 0.5. Okay, what you're going to notice is that this line right here, the grid mark, is 45 degrees. So before that would be 30 degrees, and after that would be 60 degrees. So you're still following those same angle measures that we've been working with from the exact value table on this graph. Okay, so we've got 30, 45, 60, 90, and then we have 120, 135, and 150. So you just have to think in those same increments for that. Okay, so you should be able to do it that way, or you can use your calculator. I'm going to end up using Desmos because of the computer that I'm on right now. It's going to be easier for me to show it to you through Desmos. Okay, so these are what your 4 graphs should look like. If you haven't and you need to correct them, go ahead and pause, fix whatever graphs you need to fix. And I'm going to move to the next slide. Okay, so as we compare the sine and cosine functions, we can see some similarities here. The curves are the same size and shape. Their horizontal positions on the axis differ. Actually, the sine and cosine graphs are the exact same graphs. One is just a horizontal translation of the other. Okay? The sine curve passes through the origin of 0, 0, and the cosine passes through the point 0, 1. I know some of you have heard it described as the sine starts in the soil, meaning at 0, and the cosine starts in the clouds, meaning the highest point of 1. These functions are periodic. To be a periodic function, that means that we're having some repetition. Okay, so they repeat the same cycle over and over again, and it doesn't matter where you start or stop the graph, it's going to have that same pattern. Okay, and when we go to find the period of our function, what we're looking for is one repetition of that graph. Okay, so you could start from the maximum and go to the next maximum. You could start from an x-intercept as you're heading up the graph and go to the next time you hit the x-intercept as you're heading up the graph. Or you could go from minimums to minimums, and you would be able to come up with the period. And both functions, both parent functions, sine x and cosine x, have the same amplitude of 1. They don't go above positive 1, and they don't go below negative 1. We could change the equation and make a translation, make a stretch, make a shrink, whatever we want, and change those values. But the parent functions will also always go from negative 1 to positive 1. All right. So we're going to do this problem here where it says solve the equation, the cosine of the angle equals 0.4 from negative 360 to positive 360, and we're going to give our answers to the nearest 10. Like I said, I'm going to choose to do that through Desmos. I like Desmos a lot because I don't have to do a whole bunch of stuff like I do on my calculator to try and find intersection points or try and find x-intercepts. It just kind of, I can trace a lot easier on Desmos. So here on my Desmos screen, you can see I've already put in the cosine of x And then that value that they gave me of the 0.4, I had to put it in as y equals 0.4. If I just put in 0.4, Desmos thinks I'm trying to do a calculation because they use the same entry lines. So I have to designate it as a line by saying y equals 4. So I'm going to go ahead and graph my cosine. And you can see I went from negative 360 to positive 360. I changed my window. If you're looking to do that on Desmos, it comes up here in this wrench thing up in the corner. I made sure I was on degrees. I made my x-axis go negative 360 to positive 360. And I counted by 45 degrees. Okay. And then I made my y-axis go from a little bit past what I knew the maximum and minimums were going to be of negative 1.5 and positive 1.5. And I had them count by 0.5. So there's my cosine graph. Pretty. Okay, now I'm going to graph the line y equals 0.4 because that was the other side of the equation. And there I go. And to look for the solutions to that equation, all I need to do is find those intersection points where that blue line on my Desmos intersects my red curve. And it looks like there's 4 of them. And the directions tell me to round to the nearest tenth. So that's what I'm going to do. And I can split my screen to do this. Oh, sugar. It scrunched up my screen, but it took away my intersection points that I already had marked. There we go. All right, so giving my answers to the nearest tenth, I'm seeing negative 293.6 degrees. I'm seeing negative 66.4 degrees. I'm seeing 293.6 degrees positive and 66.4 degrees positive. So that's how we would work this one out. It's mainly a calculator-based issue. Okay. So my next one, kind of going to do the same thing. I'm going to do the sine of x. So I'm going to graph the sine of x. And then I want to see where it's going to equal that expression. But this time I need to work in radians. Okay, so my graph just changed magically right now. I paused my recording and went ahead and changed my graph so you didn't have to sit through that. But I did change my cosine graph to sine, and I did change my other graph to 0.25x minus 0.3. And I also went over here to my settings and I changed to radians. And I made sure my x-axis went from negative 2 pi to 2 pi because that's what it told me up here. But I was able to leave the y-axis the same. The step here is your choice. I did pi over 4 because I knew that was 45 degrees, and that just made sense to me. So now, again, what we're doing is, and it wants 3 significant figures, because it wants all of the intersection points, and it looks like I only have 3 of them in this case. Okay, so I'm looking at 3 significant figures, huh? Let's go with the bottom one of negative 2.15. Next one up is negative 0.416. And the top one is positive 2.75. Okay, so it's just a matter of making sure you get it graphed right. And like I said, Desmos, for me, Desmos makes it easy, but unfortunately on your test, you have to be able to do it on your calculator. Okay, that's one of the reasons why we practice on them, is so that we're ready for the external exam. All right, so let's take a look at the next situation. All right, so back to full screen. What I want you to do next is the investigation that's in your book. Okay, and it's actually going to be graphing the tangent of x. So just like when we started with the sine and the cosine, you started with, like the sine of 0 degrees and you plotted that point, the sine of 30 degrees, all of those ones that we knew until you started into that pattern. Well, do the same thing with the list for the tangent values. So we know the tangent of 0 degrees is 0. We know the tangent of 30 degrees is the square root of 3 over 3. We know the tangent of 45 is 1. We know the tangent of 60 is the square root of 3. And we know that tangent of 90 degrees, notice that's not here, but tangent of 90 degrees is undefined. Let's think about what that's going to look like on a graph to be undefined. So plot the values where there's no tangent values. So for like 90 and 270, that's actually going to be an asymptote for you. Okay, and so you're connected to the points, and then you will go ahead and look at it on your calculator, whether you look at it on your handheld or on Desmos. Okay. All right, so here's my graph of tangent. I did it on Desmos. So I've got all of those. Doesn't really look the same as the sine and the cosine graph. It doesn't have that nice wave to it. And as a matter of fact, we have asymptotes in there as well. If you wanted to, we could even represent those asymptotes. They happen at x equals 90. Oh, look at that green line right there. They happen at x equals 270. You have a second one, that one. They happen at x equals negative 90 and x equals negative 270. Oops. Okay, so all of those vertical lines you're seeing are asymptotes right there. And that's because at those values, it's actually undefined. We don't have a graph of tangent. We can't, because it would be something divided by 0, which we can't have. Okay, so let's go back to full screen and let's talk about this tangent graph for a little bit. So there's another image. That one uses radians. So that's what that would look like with radians. That would, the asymptotes now would fall at your pi over 2 and your 3 pi over 2 and your negative pi over 2 and negative 3 pi over 2. Now, like the sine and the cosine graph, although it doesn't have the wave to it, it is actually considered periodic because it has a repetition to it, and we can see the beginning to the end of that repetition. So like, let's say this one's, we take one of those asymptotes right there at pi over 2 and go to the next asymptote at 3 pi over 2. We can see that this one actually has a period of 180 degrees, where the period of the sine and cosine graph was 360 degrees before it got all the way through the pattern. So the period is different for the tangent as compared to the sine and the cosine. All right. So we're going to use that idea, and now we're going to do your closure. Okay, so go ahead and do your closure, submit it, and that'll be done for today.